Hello everyone, good morning, afternoon, and evening. Dear authors and invited guests, welcome to Technical Session 7A. Myself, Adesh Bazare, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, MCT4SD 2025, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held on 11 December in Manila, Philippines, and the virtual event is being held through Zoom on 12th and 13 December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this, we have 8 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Janelli M. Mendes. Ma'am is the program head of the College of Computer Studies and Engineering at Lorma College's CLI campus, San Juan, La Union, Philippines. Her expertise includes information technology, Internet of Things, machine learning, data science, and related emerging technologies. Ma'am, I request you to please share your opening remarks with the authors.
Okay, so good afternoon and thank you, Mr. Bahare. I hope I pronounced it right. Now, on behalf of the organizing committee, it's my pleasure to welcome you all to the International Conference on Machine Learning and Computing Technologies for Sustainable Development. And we are truly honored by your presence and grateful that you have been taken the time to join us in this virtual gathering for scholars, researchers, practitioners, and industry partners. So, with that, I congratulate all, advance congratulations to all the researchers, and again, good afternoon, everybody.
Thank you, ma'am. Now, I would like to start with the papers. The first paper to be presented is a paper titled A Lightweight Deep Learning Classifier for Farm Irrigation Status Detection Using Image Buffers and Metadata, a case study from Bohol, Philippines. The paper will be presented by Max Angelo Di Perin.
Good day, sir. Am I audible?
Yes, sir, you're audible.
Okay, I'm just gonna share my screen. Is my screen visible, sir?
Yes, sir, your screen is visible.
Okay. Wait. Good day, everyone. Together with my co-authors, I am pleased to introduce myself. I am Max Angelo Pirin, a doctor in information technology student and at Cebu Institute of Technology University, and a computer science faculty member of Bohol Island State University. Our study ask a practical question. Can we reliably screen plot level irrigation status using only a smartphone photo, transmitted as an image buffer through an API, and optionally combined with lightweight geotemporal metadata? We present a pilot end-to-end pipeline using the local irrigation system assessment or the LISA platform and a lightweight transfer learning model that classifies rice plots as wet and dry in a resource-constrained field setting in Bohol, Philippines. So this work is entitled A Lightweight Deep Learning Classifier for Farm Irrigation Status Detection Using Image Buffers and Metadata, a case study of Bohol, Philippines. Flat scale irrigation information direct affects farm productivity and climate resilience. But operationally, monitoring is hard. Satellite products can be limited by cloud cover and coarse spatial resolution. And field sensors can be expensive and difficult to scale in rural settings. Smartphones are already in the field, so the motivation is to convert ordinary field images into a consistent wet-dry screening signal that can support irrigation triage and decision support. We contribute four things in this study. First, a smartphone-centric pipeline where photos are retrieved as byte buffer images from a REST endpoint. Second, we apply lightweight transfer learning using mobile-friendly CNN backbones. Third, we explicitly compare three modeling strategies: image only, metadata only, and late fusion of image and metadata. Fourth, we export and profile the model for edge deployment using TensorFlow Lite in FP32, FP16, and Int8 formats to understand the size and the latency trade-offs. Operationally, this runs inside the Local Irrigation System Assessment, or the LISA workflow. Enumerators collect plot photos in the mobile application, and the system retrieves those images as byte buffers via REST point. Alongside the image, we capture lightweight metadata such as latitude, longitude, plot identifier, timestamp, and enumerator information. This is a pilot data set collected in Barangay Zamora, Bilar, Bohol, a nearby farmland in Bohol Island State University, Bilar campus, last July 2 to 3, 2025. The data set has 40 images, cross-sectional, with one visit per plot, and binary labels, wet or dry. Labels were co-verified on site with a senior farmer, and we apply privacy protection by jittering coordinates up to 50 meters in public artifacts. We decode the byte buffer into RGB, resized to 224 times 224, normalized to 0, 1, and apply light augmentation such as flips and small rotations or zooms. Then we evaluate three model variants. First is the image only, a frozen MobileNet version 2 backbone with a shallow classification head. Second, the metadata only, a logistic regression as a simple baseline. And third, late fusion, concatenate the image global average pooling or gap vector with a small metadata MLP, then 16 to dense 8, and then classify it. We intentionally keep training lightweight batch size of 8, only 5 epochs, and add them with learning rate 1e minus 3, and binary cross entropy loss. Because the data set is small, we use two evaluation to reduce the risk that a single split drives the story. Evaluation is A is a fixed, stratified holdout with a 13 test images. Evaluation B is a separate stratified 80 by 20 split with 8 test images used for the ablations. We also prevent leakage by ensuring no image and no identical plot timestamp pair appears across train and test within a run. The key result is that the image only lightweight model already performs strongly in this pilot. On evaluation A, it achieved 92.31% accuracy, getting 12 out of 13 correct. The model appears to learn the right visual cues for wet plots, such as specular reflection and pooled water. The typical failure modes are also instructive for field deployment. Glare can mimic water sheen, overcast condition, reduced reflection, and heavy vegetation can dominate the frame and obscure the water signal. Next, we test whether metadata improves discrimination. So on evaluation B, image only reaches 0.85 accuracy, 0.89 F1, and 0.78 ROC AUC. The metadata only baseline performs worse. Late fusion matches accuracy and F1 but reduces AUC to 0.72. Our interpretation is that at this pilot scale and within the single barangay footprint, the current geotemporal features carry limited complementary signal and can introduce noise that hurts threshold-free ranking reflected in the AUC. The paper also treats this AUC drop as inconclusive that this scale and motivates richer derived features like rainfall and topography for future fusion. We also check the backbone sensitivity. We compare mobile net version 2, mobile net version 3, small and large, and efficient net version 2, B0, under the same condition. Frozen backbones, identical heads, and the same 5-epoch training regime. Mobile net version 2 achieves the strongest accuracy and the best overall metrics on this pilot split. Because n is small, we describe this as directional, but it gives us sensible reference backbone for the pilot pipeline. For the deployment, we export FP32, FP16, and int8 TensorFlow Lite models and measure artifact sizes and median proxy latency in reproducible collab CPU setup. FP16 typically reduces size by about half, and int8 reduces it by roughly 2/3. However, proxy latency can be misleading. FP32, FP16 use XNN pack here, while int8 may fall back to reference kernels, which can invert latency rankings compared to real devices. Given that, we select mobile net version 3 small FP16 as a practical baseline for on-device deployment and target int8 once NN API execution paths are validated on the hardware. Operationally, the recommendation is to integrate the model into the LISA application and dashboard, and then overlay prediction calibrated confidence on the same map used for field monitoring. The paper highlights that even within few hundred meters, irrigation status can be heterogeneous, so map-based overlays can guide targeted checks and triage. We also propose a human-in-the-loop workflow, define a low confidence band, and automatically flag these plots for recapture or supervisor review. Next steps are to expand the data set across seasons and sites, add richer derived geotemporal features like rainfall or topography, and run through on-device benchmarking and optimization. So before I end, this photo shows one of our field engagement where we presented the LISA-based workflow to our National Irrigation Administration or the NIA farmers partners during the pilot activities. This stakeholder interaction helps ensure the system remains practical, usable, and aligned with on-ground needs. Thank you for listening.
Dr. Janelli, do you have any questions here?
Okay, so thank you for the presentation, Sir Max, and congratulations.
Ma'am.
Just a few questions, sirs. Sir, how can the result of this research support now the local government units or even national agencies in improving the irrigation management and climate resilience?
As of now, ma'am, the status of this study is also extended to the community here in Bohol, but not yet presented to a somehow in a local government, but still in the NIA collaboration with us in Bilar campus, ma'am.
Oh, just a follow-up, sir. What are the challenges that you encountered while having this research?
I think when we do surveys on the farms, it's too difficult if we were just independent researchers to survey on those map availability. The status of the farm. So maybe we should collaborate with the LGUs for somehow we will transfer the application to the farmers so that the farmers will now directly use the application, and then we will just directly analyze those data, ma'am.
Okay. Thank you, Sir Max, and congratulations again.
Thank you, ma'am.
Hello. Hello.
Yes, sir.
Yeah. So am I audible?
Yes, sir, you're audible.
Okay. So yes, I have one question.
Yes, sir. Good. Hello, sir.
Yeah, hi. The presentation is good. The only thing is, right, I want to know the size of data set that you have used.
As of now, sir, we just have doing the pilot test. So as of now, we have 40 images because we're still on the pilot implementation, sir. We're not into the, we are still on the process for the full blown, sir.
Yeah, that's the reason that any result that you present on this small data set
Yes.
size, right, is still a questionable to, because as the size of data is increased, the
Mm-hmm.
performance, uh, it, it, it impacts the performance,
Yes, sir.
right? And yes, one more thing is any specific reason for logistic regression? Why you have chosen the logistic regression? As
Um,
such, we have other options available for such small data sets, right?
in the application, in the image processing, sir, we use a mobile net version 2, sir, for the training and testing. The logistic reduce, it's just for the feature importance, sir.
Okay, fine. Thank you.
Thank you, sir.
Thank you, sir. Thank you, chairs. We'll be moving towards our next presentation. And the next paper to be presented is a paper titled ASIC Implementation of a Low Power Multilayer Perceptron Neuron Network for Handwritten Digit Classification on 32 nm CMOS Process. The paper will be presented by Thiwang Pham.
Yeah. Hello, can you hear me?
Yes, sir, you're audible.
Yeah. Wait a minute for showing my PowerPoint.
Yes, sir.
Oh, shit. Can you see my PowerPoint?
Yes, sir, your screen is visible.
Okay. Hello, everyone. My name is Hung and my co-author is Bảo. We will share with you about the topic related to ASIC implementation of a system PNN for high written digit classification or CMOS process. And we have four main section in this
Excuse
presentation.
me, sir.
Yeah, because we.
It's a request. Can you please show the presentation in slideshow mode?
Oh, let me check. Chắc phải phải rồi. Ờ. Mình nhấn cái bằng tiêu chiếu rồi sau đó anh tác rồi. Dạ rồi. Dạ rồi. Anh là tác. Anh chơi tranh. Đây đúng không? Ờ. Phải là dạ. Can you see the slide transition?
Sir, the slide transitions are visible, but currently the slide is not on full screen mode.
Oh, I know, I know.
Yeah.
Có thể họ đang nhìn thấy cái màn này. Can you see the full slide?
Yes, sir. Now it's visible.
Okay, okay. First of all, we will share about theory related to our research. First, it is a neural network, and the neural network contains the list of three layers. First layer is input for processing input data, and the next layer is hidden layers, which extract the feature in the training process. And the final layer is the output layer for representing the data to be identified. And the number of each layer depends on each application, such as detecting data or classifying data. And the neural network is based on various neurons. And in our research, we use perceptron neuron with two equations like this. And each neuron acts as a basic unit of computation, and neuron receive information from previous neuron and process the information and transmit the data to another neurons. And beside that, we also build the architecture with multi-layer perceptron and feed-forward with three phases. And the first phase is initialization for assign input data, and the next phase is propagation for calculating value related to weight and bias and apply them to activation function. And the final phase is completion for the detecting the final output result. And next, we also use backpropagation for architecture, and the goal of it is to find the optimal set of the value related to weight and bias, and so that the network can make the most accurate predictions. And on the other hand, we also use the design flow related to hardware, and there are many steps related to ASIC design flow. You can see that we started from architecture design with RTL coding, such as Verilog or VHDL. And after that, we use the VHDL or Verilog into the logic simulation step. And after that, we continue to logic synthesis, physical synthesis, physical verification. And we also use various train tool of synopsis incorporation, such as VCS and DVE for logic simulation. These design compiler tool for logic synthesis, and IC compiler tool is for physical synthesis. And finally, we also use IC validator tool for checking physical layout with GDF file. And beside that, when we optimize the power on the architecture, we need to analyze the power consumption related to dynamic power and static power, like the slab. And we also use some low power technique on the architecture, especially clock gating and multi-voltage. And beside that, there are many techniques for low power, but on our research, we just use clock gating and multi-voltage. And we also have some methods for training phase and testing phase. In the training phase, we use Python with TensorFlow for training phase to extract the parameter, for example, weight and bias value. And after that, we use them into the hardware design with testing phase on the ASIC design flow. And the parameter have the format of 16 fixed point bits. And we also use the data available on the internet, such as MIT dataset. And MIT dataset has 60,000 training samples and 10,000 testing samples. And for our research, we build the architecture for the system with one input layer, one hidden layer, and one output layer. And input layer, we have 784 neurons, and hidden layer, we have 128 neurons, and the final layer has 10 neurons. And this is our architecture for the hardware on the ASIC design flow. We can see that we use the neuron network core on the ASIC design flow. And beside that, we also use object memory for some value related to weight, bias, or images. And the main core, we have 4 modules. The first module is input layer, next is output layer, artwork layer, and final module is control unit. And when we adapt the low power techniques on the architecture, we use clock gating for enabling or disabling the clock signal to each module. Or multi-voltage techniques, we also use 2 domains such as high VDD and lower VDD for 2 domains voltage to supply each module. And with some result we receive from design, as you can see, the functional verification on the training phase. The design can achieve the high accuracy at approximately 97%, and with some the result related to training loss with 50 epochs. And after training phase, we also convert the weight and bias to the format of fixed point bits number to adapt on the hardware. And this is the testing phase on the hardware. And you can see that we test with 10 numbers from 0 to 9. And the accuracy we can achieve is 90%. And this is some reports from logical synthesis. You can see the number of clock gating elements. And beside that, we also declare the format of 2 domains supplied in the logic synthesis. And this is layout. This is final layout we implemented on the IC compiler tool. And we separate with 2 domains, and with the design we can clean the DRC, LVS, and logic equivalent checking with final layout. And beside that, we also achieve the area of 0.144 square millimeter. And beside that, we also achieve accuracy of 90% and total power consumption of this architecture is 1.77 milliwatt. And this
Excuse me,
is
sir.
some, yeah,
Just wanted to remind you of the time limit.
sorry.
Just wanted to remind you of the time limit here.
Oh, okay. And this is some compared with other results related to my design. Yeah, and this is some advantages and disadvantages. Advantages are balancing between frequency, area, and power. And this is some references in our presentation. And thank you for your attention.
Yeah, hello.
Yeah, hello.
Mm.
Hello, sir.
Congratulations. Yeah,
Yeah,
congratulations. It's a good presentation.
sorry.
Yeah, congratulations. It is a good presentation.
Sorry, I cannot listen clearly.
Yeah, am I audible now? Hello.
Yeah, now we have two authors, two main authors now.
Am I audible?
Yes, sir, you're audible.
Okay. So it was a good presentation. My question is about have you considered any pre-processing data before actually processing that?
Pre-processing. Uh, Sorry, we cannot hear you clearly, and we don't know how we don't know you ask what. Hello, sir. Can you hear me?
Yes, I can hear you. Can you hear me?
Yes.
So my question is, have you considered any pre-processing technique?
Processing techniques on the software domain, like this
Pre,
one.
no, I'm talking about pre-processing techniques. Before actually applying this model, have you pre-processed your data or you have used this as it is?
Ờ, thì ông Hạ là có tiền sử lý data hay không? Actually, we not have any step for pre-processing data. We just download from the Kaggle website, and we use directly the dataset from it.
Okay, fine, thank you.
Okay, thank you.
Okay, so thank you for that presentation and congratulations, Mr. Pam. Maybe my question is I'll be posting it in the group chat.
Okay.
Okay, so that you can read at the same time. So why did you choose the multi-layer perceptron? Aside from or over other neural network architectures?
I think maybe it depends on the hardware design flow because when I choose a multi-layer perceptron on hardware, it very simple for us to implement on the hardware, and it can be saved for the resources. But when we use another neural network architecture, it can be achieved for the large resources on the hardware design. So this is my reasons on the architecture.
Okay, thank you so much.
Yeah, thank you so much.
Thank you, sir. Thank you, chairs. We'll be moving towards our next presentation. And next paper to be presented is automated test marking using multimodal AI techniques, a systematic literature review. The paper will be presented by F.K. Musafri. Do we have the authors or co-authors for this paper present?
Yes, I'm here. Thank you. Can you
Yes,
see
ma'am.
my screen?
No, ma'am. Can you please retry sharing your screen?
Can you see now my screen?
Yes, ma'am. Now it's visible.
Okay. Good morning. I don't know if it's good morning on your side or good afternoon. My name is Kiria Musafiri from Chania University of Technology. Thank you for the opportunity to present today. My research focuses on automated test marking using multimodal AI techniques, which addresses the growing challenge of marking open-ended student assessments at a scale level. I will briefly take you through all the problems, the systematic review, the process, the architecture, the key findings, and the implication for higher education. Universities are experiencing rapid growth in student numbers, which increases the marking workload for lecturers, as we know. Manual grading is time-consuming, inconsistent, and affected by fatigue and subjectivity. The existing automated system it still struggles with three main issues based on what I've found. Paraphrase or alternative valid answer if maybe a student is trying to like as we know we can use if maybe someone say love and you want to use a different word for love, so the existing system could not actually identify the similarity if somebody else use a different word. So it struggles also with handwritten response and OCR errors, lack of fairness consistency across students. These challenges highlight the need for a more reliable, scalable automated marking solution. The objectives of this research was to develop a multimodal automated test marking system. The system is designed to handle both handwritten and typed response using OCR and document extractions. It integrates BERT-based semantic embedding with an hybrid scoring model combining similarity, keywords, relevance, and concept coverage. The goal of this system is to improve fairness, accuracy, marking efficiency for higher education institutions. Our systematic search was conducted across two major databases, IEEE Explore and Scopus. We were using terms as automated essay scoring and written assessment. We have identified 542 studies, and we have removed duplicates. We have screen title, and we only pick high quality study were considered. We apply clear inclusion criteria focusing on peer review study from 2018 to 2025 that implemented automated scoring with measurable outcomes. Studies were excluded if they lack performance metrics, were opinion-based, or focus only on OCR without scoring. After full screening, 32 studies were included in the final review. Quality assessment considered validity of evaluation, transparency of dataset and replicability to ensure reliability and findings. From the selected study, we extracted on model type, modalities, and dataset and performance metric. We can see that the ETF, IDF performance was 72%, the Words to Vect was 78%, the SPERT 91%, but the hybrid one, which is a combination of different techniques, it was the highest one with 93 to 95% scoring. The proposed system processes both handwritten and submission in a unified pipeline. Handwritten response are processed through an OCR and with correct steps, while typed documents are extracted directly from the papers. Both are routed into the NLP, into the natural language processing engine, which generates a SBERT embedding to capture semantic meaning. The hybrid scoring model then combines semantic similarity with keywords and concept checks. Results are stored in the database and presented through the dashboard for transparency and lecturer verification for both the admin and the student. The hybrid approach improves accuracy, fairness, consistency compared to the single method scoring. However, challenges remain, especially with low quality handwritten. If maybe a student, if the handwritten is very poor, so the system still struggles a little bit with that one. Incomplete marking memo, if maybe the lecturer submit a memo that is incomplete, it will not actually give the correct answer or outcome. And semantic ambiguity in student response. Feature work includes integrating large language model for reasoning. For example, if we have a subject that we need to give to a student so that they can discuss about a specific topic, because every student has their own way of thinking. That's why we want to integrate with the large language model for reasoning. Adapting rubric, expansion, pilot testing, and real exam setting. This development will help move forward fully scalable and trustworthy automated assessment. In conclusion, this research demonstrates that multimodal automated marking system can significantly improve efficiency and fairness in higher education. The hybrid scoring model achieved 93 to 95 accuracy. It outperformed traditional approaches. The system shows strong potential for institutional adoption as university transition to AI supports assessment. Thank you. Any question?
Yeah, thank you. Thank you for the presentation. I hope I am audible.
Yes, you are.
Okay. So my first question is related to for
Yeah.
which language you have tested this research?
So, sorry if I may ask, can you please rephrase your first which language?
Yeah, which language means
Oh, language. Oh, I use English. I didn't use a lot of language. My research was based purely on English, but
English.
purely English. But as we are continue building the system, we're gonna try different language to accommodate.
Okay.
Thank you.
And the second thing is you mentioned that the hybrid model outperforms TF-IDF and BERT and any other models, right?
Yeah.
So can you elaborate what kind of hybrid approach you have chosen here? Hybrid in a
Okay.
sense, how are you combining the advantage of multiple models, or what kind of hybridization is there?
Okay, thank you so much for your question. By hybrid model, I mean, as we know, there is BERT and there's also BERT. For for the hybrid model that I mean is we are not just checking if maybe the words are similar, if maybe someone writes marking and the other person mark, the memo is sorry. We are not just checking the similarity of the words. We are not just checking A and A, B to B. We are evaluating the meaning. So we are using spurts. Not only we are using spurts, we are using also key scoring. The key scoring, I mean, it's checking, for example, if maybe for photosynthesis, if maybe we ask a student, which word can we use in the photosynthesis? If the student says sunlight, we know that it will not be another answer. If maybe, it will not be another answer. So we use keyword score. We use also concept coverage. But for other systems, they were only focusing on one thing. It's either using spurts or using other methods. It was not combining because it was not combining all the coverage so that the student will be marked correctly.
Okay, all right. Thank you.
So sorry. So for the hybrid, it's actually checking the meaning. It requires terminology and the complete sentences. Yeah.
Yeah, got it.
Thank you.
Okay, so questions and congratulations,
Thank you so
Miss
much.
Kyra. Just two questions. First is what challenges and barriers to the real world adoption did you encounter during your research?
During my research, I encountered a lot of challenges. The first one, which algorithm or to use. Encounter like some also data sets. Where can I find material to actually test this system? Likely the university came through and provided with me with some memo, and also what I've experienced as challenges is to read certain and written that was not well written. So yeah, so far that's what I've experienced as challenges.
Okay, so my next question now. So what would be the future direction of your research?
My future direction of this research, I want to integrate the large language model. I don't just want students to memorize a specific answer. I want students to be able to write their thoughts and the reasoning so that the system will be able to mark also the way the student think. It should not only be about cramming answers, but about how they think, how they thought. Yeah, that part, I think it's very important. Yeah.
Okay, so thank you and congratulations again.
Thank you so much.
Thank you, ma'am, and thank you, chairs. We'll be moving towards our next presentation. The next paper to be presented is evaluating 7S compliance in Bohol Island State University, feature importance and logistic regression models for organizational readiness assessment, and the paper will be presented by Max Angelo Di Perrin.
Good day again. Am I audible, sir?
Yes, sir, you're audible.
Okay. Is my screen visible, sir?
So your screen is visible.
Okay. Good day again, everyone. I am Max Pirin from Bohol Island State University, and together with my co-authors, I will present our study titled Evaluating 7S Compliance in Bohol Island State University, Feature Importance and Logistic Regression, um, Models for Organizational Readiness Assessment. This work focuses on how we can use simple, interpretable analytics to understand organizational readiness through the 7S compliance audit, particularly in the context of Bohol Island State University. Our overall goal is to assess the 7S organizational readiness using data analytics. In our framework, 7S refers to shine, sort, straighten, standardize, sustain, spirit, and safety. To do that, we used logistic regression, interpret results using feature importance, and apply validation techniques so that the results are not based on a single split. This study matters for three reasons. First, 7S supports clean, safe, and efficient campus operations. Second, we want to identify which organizational areas are most associated with compliance outcomes so leadership can prioritize intervention. And third, it lays a foundation for data-driven decision-making at Bohol Island State University by turning audit results into actionable insights. Our methodology begins with audit data on compliance with 7S components. We then perform pre-processing, meaning imputing, missing values, and scaling. After that, we train logistic regression models, both binary and multi-class, depending on the target definition. We validate using k-fold cross-validation and tune parameters using grid search, mainly to reduce the risk of overfitting on a limited dataset. Here, compliance is encoded as 1 for compliant and 0 for non-compliant. We handled missing values through imputation, scale features using standard scaler, and apply an 80-20 train test split. This ensures the model is learning pattern rather than being biased by feature scale differences. On this slide, the chart shows the distribution of 7S components present in the dataset. Some components appear frequently while others are underrepresented. This matters because machine learning models learn best when classes and categories are balanced. So if certain components appear rarely in the audit data, the model has fewer examples to learn from, and prediction for those components become unreliable or biased. This is the confusion matrix summarizes how the model perform across components. Ideally, we want a strong diagonal, meaning correct prediction. But in our case, one comment stands out as predicted well, while many others are not learned effectively. This is a classic symptom of an imbalanced data set. The model becomes good at a small part of the space and weak everywhere else. So this table reports precisions, recall, and F1 score. The altar component achieved an F1 score of 0.75, but many other components shows zeros. That does not mean those components are unimportant operationally. It means that the model did not detect true positives for them under the current data distribution. So the metrics here are not just the results, they are the diagnostic signal. We need better coverage and balance in the audit data set. Our overall model accuracy is 8%, and again, altar component is the best predicted. Many components like books and cabinets shows zero prediction performance, and the slide highlights the key reason, small and imbalanced data set leading to model bias. So we treat this as an early baseline rather than a final predictive system. Now, this is the most actionable part of the study. Even with the modest accuracy, logistic regression is interpretable, so we can inspect which organizational areas influence the predictions. The top contributing offices were the supply office, quality assurance office, and planning office. In logistic regression terms, these features had the largest coefficient magnitudes, meaning they were most influential in predicting compliance outcomes. On the other hand, some offices had zero importance, including the admin office, HR office, or human resource, and general education office. This is an important clarification that low importance is not the same as real-world irrelevance. The slide notes this can happen due to limited data, lack of variation, or missing values. So the immediate application is to improve data representation for these areas. This figure visualizes feature importance across many offices and rooms. The tallest bars corresponds to the strongest influence, consistently with supply, QA or quality assurance, and planning. The near zero bars highlight where the model learned little to nothing, usually because the input data was not informative enough. Practically, this plot acts like prioritization map. It tells us where the current audit signals are strongest and where we need to strengthen our measurement. To summarize, limitation, accuracy is constrained by the small, imbalanced data set, and logistic regression being linear can miss complex relationships. But the insights still valuable. Even a simple interpretable model can identify where to focus on the 7S improvement efforts, provided we treat the results as guidance and continue improving data quality and coverage. Our conclusion and recommendations are straightforward. Logistic regressions provides a data-informed starting point for accessing 7S readiness. Quality assurance, or QA, supply and planning emerge as a key drivers, while admin, human resource or HR, and general education offices need better representation in the audit data. For the next actions, collect more balanced, high-quality data, explore nonlinear models such as random forests, and use these feature insights to guide targeted intervention and future audits. Before I close, this photo captures our 7S evaluation activity in Boholalan State University, Kandihay, together with the evaluators and the research team. It reflects that this work is grounded in actual campus quality initiatives, and our intent is to support continuous improvement through evidence-based monitoring. Daghang salamat. Thank you for listening.
Okay, congratulations, Sir Max, again for this presentation. I guess I'll be
Thank
the
you,
one
ma'am.
to ask the first question. Sir Max, why did you choose logistic regression aside from more complex machine learning models for assessing now your result?
Um, for the data gathered, ma'am, is still in one campus, so I just try to train, or I mean try to utilize logistic regression for based on the data was gathered, ma'am, based on the features also.
Okay.
Yes,
Okay.
ma'am.
Did you already presented this one to your administrators?
I
Which is
presented with
this is
yes,
a
ma'am.
good research actually for decision making of your
Mhm.
administrators. Did you already presented it to them?
As of now, we presented here at the in-house, ma'am, research in-house, but not yet in the admin side, ma'am, in research
Oh.
in-house.
So same question with the other researchers. What would be the future path of this research?
Yeah, for as of now, we are still on the 7S evaluation up until now. So the plan is we will gather all the data of the university, since this research is focusly on the Kandihay campus, because we are also assigned as an evaluator there last year. So the data was so limited. So maybe the recommendation, we will gather all the data so that we will come up a better insights, ma'am.
Okay,
Yes,
thank
ma'am.
you, Sir Max, and congratulations again.
Thank you, ma'am.
Yeah, hello.
Hello, sir.
Yeah. So my question is regarding, as you mentioned, k-fold cross validation that you have used in your
Yes,
experimentation.
yes, sir.
Can you just tell me what will be the value of k that you have set for the experimentation?
Okay. I forgot the the coding, sir.
Go back. Go back. Yeah, back.
This one, sir.
No, back. Yeah. For validation, you said in your methodology you use k-fold cross validation, right?
I I didn't remember where's but I have the code in my Google Colab.
No, because that affects the
Yeah,
performance,
yeah,
right?
yes,
Value of k
yes, sir.
has the major importance over the result.
Yeah. I
Okay,
I didn't remember, sir.
it might be 10-fold cross validations,
Mm.
ideally, right? It depends what you choose. Okay, the second one
Mm.
is if it is not feasible, right? One more question is regarding how do you identify that features are not relevant? You said certain features are not relevant and we haven't
Uh,
considered it.
because in the evaluation forms, we have we will follow one uniform questionnaire, but there are different types of offices. So some of the questions are not applicable to, like, for example, the offices. Um, some of the questions in the offices are not applicable to the classrooms, and vice versa,
No,
sir.
but how do you identify it?
Pardon, sir.
How do you identify it? It should not be human perception based, right?
Okay.
It should be automated process to identify the features which are not relevant.
Maybe um I mean the um the data that's is almost not applicable, sir,
Yeah. Okay.
because it's
Let me think on
NA.
it. Yeah.
Yes, sir. But the still on based on the data, sir. Because
Mm.
one is complied, zero is not complied, and for not applicable is NA.
Okay. Yeah.
Yes, sir.
Yeah. Thank you. We may continue with the next.
Thank you,
Thank
sir.
you, sir.
Thank you, chairs. We'll be proceeding with our next paper. The next paper will be presented by Prince Kelvin Wusu, and the paper title is Implementing a Wearable IoT-based Smart Waste for Worker Safety in Hazardous Environment. Do you have the authors and co-authors for this paper?
Yes, please. Am I audible?
Yes, sir, you're audible.
Um, let me share my screen.
So will you be presenting in place of the author?
Yes, please. Please, can you see my screen now?
So your screen is visible.
All right, thank you. Good day. My name is Matthew Wandan, and on behalf of my co-authors, I'll be presenting our paper titled Implementing a Wearable IoT-Based Smart Vest for Workers' Safety in Hazardous Environment. This study focuses on how low-cost IoT technologies can be practically applied to improve real-time safety monitoring for workers operating in harsh conditions, particularly in a developing region such as Ghana. I'll begin with the motivation and problem statement, followed by a brief review of related literature. I will then explain how materials, methodology, testing approach, present the results, discuss key findings, and finally conclude with future directions. Workplace safety remains a serious challenge in the hazardous industries such as the mining, construction, and chemical processing. Workers are often exposed to toxic gases, high temperature, and unpredictable environmental conditions. While traditional personnel protective equipment offers physical protections, it lacks real-time monitoring and cannot respond to sudden environmental changes. With recent advances in IoT and wearable technologies, it is now possible to continuously sense environmental parameters and trigger alerts instantly. Our motivation was therefore to design and implement a low-cost modular smart vest that can monitor hazards in real time and alert workers or supervisors before conditions become life-threatening. Existing research shows significant progress in gas sensors materials, with improvement in sensitivities and miniaturization. However, a major challenge remains sensor cross-sensitivity, where temperature and humidity interfere with accurate gas detections. Several studies also highlight the need for proper calibration strategies to reduce sensor drifts and false alarms, especially in harsh environments. These challenges informed our sensor selection and testing strategy. Although low-cost IoT safety devices exist, they often struggle with durability, accuracy, and real-time communications in extreme environments. Importantly, most prior studies focus on single sensor or isolated device rather than integrated wearable safety systems. This reveals a clear research gap for a modular multi-sensor low-cost smart vest, which our work aims to address. This table shows the components we put together, the purpose for each component, and the notes on selection. So we have the Arduino Nano, the MQ sensors, the 2 and 7, the DH22 for humidity monitoring, the GPS model, the GSM model, and the panic button, and the battery and regulator. And we use the Arduino IDE using C++ to develop the firmware. We adopted an incremental development model where each subsystem was developed and tested independently before we put them all together. Individual models such as the gas sensors, temperature and humidity sensors, GPS, GSM, and panic button were first validated using the Arduino serial monitoring. Afterwards, integration and calibration tests were performed to ensure accurate threshold behavior, correct GPS-based alerts, and stable system operation once mounted on the vest. The prototype was built around Arduino Nano connected to gas sensors, a DH22 sensor for humidity, GPS, and GSM model. Power was supplied using a battery pack. We initially tested the circuit on a breadboard and later mounted all the components onto the vest, ensuring portability and ease of wear for real-world use. Each model was tested independently. The MQ gas sensors responded appropriately to smoke and carbon monoxide. The DH22 produced stable and accurate temperature and humidity readings. The GPS and the GSM model together consistently acquired location data and successfully transmitted SMS alerts to supervisors. During integration testing, all the models worked together seamlessly. Once a hazard was detected, the system generated low latency SMS alerts containing GPS coordinates within few seconds. Also, it's beeped by using the buzzer on the vest for the worker to also know that he is moving around hazardous areas. This performance aligns well with recent findings in wearable safety systems. We conducted repeated hazard simulation to test reliability using gases, smokes, and heat. In all cases, SMS alerts containing sensor readings and Google Map location links were successfully delivered, as you can see on the screen, the SMS message. This confirmed that the GSM-based alert remains effective even in areas with poor or unstable internet connection. The results show that the MQ2 and the MQ7 sensors detected smoke and carbon monoxide within 3 to 6 seconds. Temperature and humidity readings closely match a reference weather station with minimal deviation. SMS alerts were delivered in average of 4.8 seconds, and GPS accuracy was within plus or minus 3 meters in an open environment. Battery tests showed approximately 6 hours of normal operation and about 3.5 hours during frequent alerts, which means if the environment is much hazardous, more alerts will be sent, so they reduce the power of the battery. Our findings show that integrating multiple sensors offers
Excuse me,
better.
sir.
Hello.
Just wanted to remind you of the time limit here.
All right, sure. Okay, our findings show that integrating multiple sensors offers better protection compared to single-purpose safety devices. The alert speed and the GPS accuracy meet requirements for industrial safety wearables. However, power consumption and long-term durability remains a challenge, consistent with finding from related studies. Using SMS rather than cloud-only communication significantly improves reliability in low connectivity areas. So places without connection can rely on the SMSs. In conclusion, the smart vests demonstrate an affordable and practical safety solutions to hazardous work environments, such as Ghanaian industries. The system successfully detects hazardous gases, monitors environmental conditions, and sends GPS-linked alerts in real time. Future work will focus on improving power efficiency, enhancing durability, and integrating cloud dashboards, predictive analytics, and multiverse monitoring for large-scale employment. Here are our references, and thank you for listening.
Okay, congratulations, Sir Matthew, for that
Thank you very much.
presentation. Some few questions, sir. What would be the main limitation of the current prototype? So in terms of the battery, the sensor accuracy, and then even the false alarm. So what are the main limitations?
The main limitation is um, one I'll say is the battery, and two, the strength of the sensors we are using. We identified that there are many sensors that we can use, but for the prototype, we use the basic MQ7 and MQ2 for prototyping. For now, those are our limitations. Ongoing, we will look for better sniffers and sensors to implement. But for now, the battery and the quality of the sensors we are using now is our limitations. And there's other limitation that falls outside the question you asked, which is the industry players agreeing with us to mount these wearable for their workers. That's also another thing we are facing, another challenge we are facing.
Another question, would you mind me to ask? How
Oh, no problem.
much? How much would be the whole prototype?
All right. In Ghanaian currency, before all the gadgets that we bought sum up to almost 500 cities, which a dollar to cedi right now is $1 to 11 cedis, 27 pesos. So doing the calculation, it will be 11 cedis, 11 times 500. Now, 11 divided by 500 divided by 11 rather. That is in dollars. So if I can do a calculation, permit me to end the sharing. Then I can answer with the calculator.
Okay, so thank you for that, Sir Matthew, and again, congratulations.
Thank you very much. And the answer is $45. Thank you.
Thank you, sir. Thank you, chairs. We'll be moving towards our next presentation. And the next paper title to be presented is Land Network Traffic Anomaly Detection and Classification Framework. And the paper will be presented by Devaraju BM.
Yeah, good evening. Am I audible?
Good afternoon, sir. Yes, sir.
I'm going to share the slides.
Sure, sir.
Yes, you can able to see now.
Yes, sir. Your screen is visible.
Yeah. My research work is on land traffic anomaly detection and classification framework. So myself, Devraju, and my colleagues Hanjan Kumar, Hemant, and Prasant Kumar. Okay, these are the outlines of the research work. So coming to the my research work. So we know that intrusion detection system helps to identify the unauthorized attackers in the computer network. So basically, we have two types of IDT systems. So one is the signature based. So knowing that known attacks detection or pattern known already for them, the IDT will IDS will go to detect the attacks. Example, device attack kind of things. Second kind is anomaly based IDS. So this system detects unknown attacks by identifying the unusual behavior of the pattern. So example, unusual IP address coming to access some certain data, or the other domains try to access data for our networks data. So our research work is investigate random forest, a machine learning algorithm to detect the anomaly and the land traffic using the real network as well as synthetic data, that is NSL KDT data set. So this research source perform extremely well detecting the attacks, and if any deviation happens in the network, so it gives a very high accuracy. So the problem statement for this our work is, so we know that network faces several harmful attacks, starting from denial of service to vulnerability and remote to local user to root. So the current existing system IDS is rule based, and it has a slow and expensive for the system. For the large traffic, to identifying the analysis manually, it is very difficult, impossible. And zero day attacks bypassing traditional tools. So even 0 day attacks can be easily traced by attacker, and they can bypass. So therefore, the goal is for our research is to detect intrusions effectively with the machine learning based systems that minimizes the false alarm. So proposed system, we are proposing proposed a random forest on both real land network data as well as NSL KDT data set to detect major attacks in the data set. So the attributes are many. So we are constrained. We have reduced what is it, features to 15. So important features we called. So from the 15 features, we could are able to detect or identify whether the data has a normal or attacker data. So this 15 features again will be selected through information gain technique, and we can also use the recursive feature elimination to calculate the select the features. So these are the main features we have chosen. So service flag, source byte, destination byte count, destination asked different, and so on, IP address, all those things. So with respect to algorithm, random forest, as we know, is a supervised machine learning algorithm. So it uses many decision tree to predict the output. So basically, it is works on majority voting rule from the several trees. So by doing this, we can prevent the overfitting and improve the accuracy of the model. So each tree can be built by constructing the bootstrap sample or by choosing the random sample from the data set to create a data sample for the model. So only M features means among many features, we're going to take minimum features, that is the small M features are randomly selected from the capital M features. The best split is chosen based on the information gain. So we have calculated for each and every features using the information gain and what is its weight. So based on that, so we have created a tree, and through that we have traced whether the pattern is attack pattern or any attack or normal data. So that's how we have constructed the random forest for many trees. So by using the feature selection, we can able to reduce the model complexity, overfitting, and computation time. So use the information gain to select the features. So as for our data set, we have classified the 4 attacks. So one is DOS attack, denial of service. So this makes service unavailable for the overloading the system. The second type is remote to local. Attacker has no local account, but again, we try to access in our network. The third one is root user to root. Attacker starts with a normal user account, but he's an attacker in the network. The fourth one is a probe. So it is a network scanning, we call it, is identifying the vulnerability in the system. So these attacks could able to identify through our model. So this is a system architecture. So we called as a LAN intrusion detection system architecture. So we are just taken the raw data set. The raw data set is length of so 126,000 rows records and 42 features. And next that we have pre-processed that data, just removing the outlier or noisy data, handling missing data, and identifying and encode the categorical variable things is data pre-processing. And as we as I told, feature selection, we have used information gain. So almost 15 features we have chosen to select the attack type. So then we have trained our model by bootstrapping sample or to create a n number of trees. Then we have used testing. So each tree will be each tree will be voted, and at the random forest we will take we have taken majority voting to decide whether the data is an attacker data or normal data. That is attack classification. So we have used a methodology to calculate the information gate to choose the best attribute or more weightage attributes. So IG is a information gate. So we have calculated entropy for a data set, for a total data set, and we have calculated sampled entropy after splitting. So before splitting minus after splitting. So it gives a actual information gain weightage. So then we can able to create a tree. So where each possible value V of a feature A and T V is a subset of the total total features for a particular feature value. So TB by T is a proportion weight of the
Excuse me, sir.
subset. Yeah.
Sorry to interrupt you. Just wanted to remind you of the time limit here.
Yes, sir. And so we have calculated entropy for each subset, and we are compared. We have calculated the gain. So if it is a entropy is higher, then we understood that is a mixed class. If the entropy is low, we understood that is a class is we can create the classes properly. If information gain is high, it is very good for separating the attributes for weightage, for giving a weightage to the classification. If it is low, it does not give a full separation for the classes. So this is the result we got. So for a normal, almost prediction classes, we got almost correct. So accuracy is very good. Even device attack, we got excellent result, almost predicted correctly. And probe, almost correct, excellent. Only R to L and U to R, the prediction class are a little lower, but even then it is okay. So overall accuracy, we have come to know that it is more than 99%. And recent recall and F score, from this we can come to know the model is effectively detect the intrusion from the LAN network. Okay. Regarding with respect to conclusion, we have used both real network dataset as well as synthetic dataset to predict whether it is an abnormal or attack dataset. So we have used random forest, successfully identifying the malicious attacks, and significantly improves the intrusion detection accuracy in the LAN environment. Our research proven that random forest can serve the reliable and strong defense layer for the modern networks. So these are the reference, we did it. Thank you. Any questions, please?
Okay. Thank you, Devraj sir. Hello.
Yeah.
Yeah, thank you. It was a wonderful presentation and a very good work.
Thank you.
Yeah, my question here is only one thing is about why random forest? Why not any other?
Yeah, random forest.
thought
See,
of?
if we take a decision tree, we have to go for only for voting. Based on voting, we have to decide whether it is a attack or not, and it gives accuracy is very low. So in the random forest, we have to take the entire data set, we have sample it, then we have collectively take the majority voting. So that gives a good accuracy.
No, so my question is related to not only decision tree or random forest. It is like in a recent research, people are using more advanced version than random forest. Maybe somewhat slightly modified random forest or so.
Yeah, yeah.
You may think of, right, or you may have a comparative analysis if random forest is generating a very good result compared to others. You may have some comparative analysis that why random.
We did the comparative analysis. Even then, random forest gives the same level of results. So now we are planning to move to the deep neural network to analyze the same.
Yeah, exactly. Yeah.
Thank you.
Thank you.
Yeah, I do agree with Dr. Bat that there are some algorithms that you can apply. But my question now would be, how can the organizations use the result of the study to improve now their current IDS deployments?
Pardon? Please repeat it again.
How can organizations use the result of this study to improve their current IDS deployments?
Yes, we have our own lab in our university and colleges. We have our own LAN connections, different LANs. So we are just model such a way that we are gathered the data through different systems, the LAN, by running the Wireshark, and from that we can able to analyze the data, and that will be useful for the study purpose and improving the how to protect our firewall systems. How can improve for our firewall systems?
Okay, so my next question now would be, what would be the future improvement of your study? So are you going to have hybrid IDS approaches, or you're going to apply it on online learning, something like that? So what would be the future improvement?
So we are just improved the what is that? We did the random forest. We are using random forest. We have done the work. So next for large data, we have done only for the small network. We go for large network. Then the obviously the data size is very huge. Then we are planning for deep learning neural network to predict the attacks.
Okay, thank you so much and congratulations. Thank you.
Thank you.
Thank you, sir. Thank you, chairs. Moving towards our next presentation. The next paper title to be presented is Secure e-voting with fully homomorphic encryption, and the paper will be presented by Swati Nikam. Do we have the authors or co-authors for this paper? Seems not. Moving towards our next paper, the paper title, Strengthening Cybersecurity Culture for Emerging Technologies, Case Study of Namibia's Telecommunication Sector. The paper will be presented by Esther Anjala. Do we have the authors and co-authors for this paper?
Yes, I'm here.
Yes, ma'am.
Okay, I will be sharing my screen quickly. Just a
Sure, ma'am. Are you facing any technical issues, ma'am?
I click on share. It says like it's still coming through. Perhaps. Can you see my screen?
Yes, ma'am. Your screen is visible.
Okay, thank you. I just want to put it in a presentation mode. Okay, I hope you can see the screen fully. Good
It is
day,
in
colleagues.
slideshow mode. Can you please change it to full screen?
Excuse me.
Yeah, the view is not currently on a full screen mode.
Okay, let me do. How about this?
Yes, ma'am. Now it's perfect.
Okay, thank you. Good day, colleagues, and thank you for the opportunity. My name is Esther Angela. I'm presenting on behalf of my co-author, the Strengthening Cybersecurity Culture for Emerging Technology, a case study of Namibia telecommunications sector. So the background of this study was really motivated by a digital transformation in telco that have accelerated rapidly, and emerging technology on the other side, they are here to improve their efficiencies as they also introduce vulnerability complexity. So despite the advanced technological tools that we are using, most of the breaches still come from the human component, which is the weak security practices and the organizational culture. So again, on the background, we just here to say that it's a national critical infrastructure supporting essential economic, governmental, and societal function. The telecommunication sector actually require a robust cybersecurity measure in order to ensure that it's stable and also reliable for interconnected digital ecosystem. So this static problem context emanates from a telecommunications sector, which is a prime target for cyber attack. And I think we all aware that telecommunication is a hub where sensitive personal information actually are kept. That include your core data record and your personal information when it comes to signing up the contract and so forth. So insider threat and human errors are increasing on a daily basis, and this is mainly driven from the lack or insufficient training, and also the technical control that exists, the framework that we know well articulated in telco are there, but they lack the behavior and the cultural practices or guidelines. So as a sector-specific cybersecurity framework would be a solution to address this problem. So the research aim was really for us to develop a cybersecurity culture framework that is tailored to telecommunications, while it is addressing the human and organizational culture and the behavioral vulnerability. The research objective really focus on how examining the human and organizational factor that influence the cybersecurity, and also to identify the gap in the current security practice. Then we also looked at the objective was also driven to explore the perspective across the management, the IT and the non-IT staff member within the organization, and also for us to develop a refined sector-specific framework. So the literature review of this study have given us some insight where it clearly pointed out that technical framework like the NIST and the ISO standard are there, but still not sufficient. It have also indicated that the key factor that is influencing the cybersecurity culture are driven from the cultural and behavior for employees. And it also highlighted that the best practice and strategy exist that can complement the technical framework that are known. So in this literature, we have come to a clear understanding that the gap of sector-specific cybersecurity culture framework in telecommunication is for real. Moving on to the next slide. This study have applied the qualitative case study method, and we have then covered 25 participants, and the reason of 25 participants is that we have reached the saturation at the interview stage. So a semi-structured interview was applied, and then we have also used a thematic analysis to analyze those data with the focus of a lived organizational experience. This study then have highlighted the key findings that we got from the literature and those one that we got from the data collection. It heavily indicated that there is a weaker leadership visibility in cybersecurity, training that are happening or awareness, they lack continuity and they are not so role specific. Role specific meaning if a personnel is sitting in IT and the person that is not sitting in the IT or say non-IT, you would want to give the IT personnel a specific knowledge how to secure the environment, while the non-IT, you need to be able to equip them how should they respond. For example, if they receive a phishing email, what they should be doing. And also the other finding that we get from the study is that the gamification and the recognition motivate secure behavior. So most of the feedback that come out, it's really highlighting that component that people feel motivated if the training is interesting, and also they get a reward for their effort. So, and then the other component is also that the security champion are more effective than the top-down directive, where employees feel more comfortable to speak to co-colleagues rather than getting the instruction from top down. So in this study, we have then come up with a refined cybersecurity framework, which is specific for telco. And then this framework has 6 core components that we would want to use and complement the existing framework. So this framework are taken from the leadership commitment and visibility, policy review, and the clear communication. At the policy review is where we indicated that the policy should be reviewed in cycle, where you should consider the evolving emerging technology that are coming in the space. So the role-specific training, which is called security education and training awareness program, should be rolled out, and it should be a continuous process, not a once-off. Then the framework is also encouraging the collaboration and feedback mechanism to say that if there's any communication or a change, this collaboration should happen when you are reviewing your policy or when you are coming up with a new initiative, and also make sure that you're giving feedback to the employees. So another component that come out stronger is the security champion, where we also understand that employees believe that if we have more people at the operational level advocating for the security, it's easier to be embedded into the culture. And then the last one, which is recognition and incentives, where employees feel more motivated to do more and they want to be the one receiving the award and the recognition at the end of a cycle or semester. So this slide is only just showing us the diagram of the framework, where we have highlighted the components that are very critical for us to implement this developed framework, with the sub-process that it should follow, and then the output, which is taking us back to our main purpose, which is the strengthen organizational resilience, reduce human resources vulnerability, enhance security awareness and behavior, and sustainable security culture. Going forward, should we implement this framework? So then in this slide, we only just talking about the practical implication when we embark on this, implementing this framework. So it strengthens the national critical infrastructure, like I highlighted earlier, that telco is one of the critical infrastructure as it supports all the essential communication.
Sorry to interrupt. Just wanted to remind you of the time limit here.
Thank you. So it also reduce the human factor vulnerability when you have your employees trained and they know their security responsibilities. It supports safe adoption of AI, IoT, cloud, and 5G. What does that mean? It says when we have this framework implemented, it will also enable the organization to make sure that when we are deploying AI model for usage, it should follow ethical defined policy and practices. Configuration of AI should follow a certain standard, and data within the cloud environment should be protected at a certain level. So, and then it also promote cultural accountability, where employees will be actually able to advocate for their security and not wait to be told. So in conclusion, we're really just saying that technical control alone are not sufficient. The culture determines organizational resilience, and the framework strengthen behavior and the leadership security. They add value to our daily operations. And also this framework is applicable across critical digital infrastructure or similar organizations that are undergoing through the same digital transformation. Thank you for listening, and I will take questions.
Okay. Presentation, ma'am, and congratulations. Just a few questions. What would be the difference of your study with the available with the other studies available online?
Thank you, Doctor. What I have what I can confirm confidently is that the existing framework, like the NIST and the ISO standard, those one are stand or framework that have a strong technical governance and compliance guidance. However, they are limited on the behavior, cultural, and the motivational for the human-centric. And my framework, or this defined framework, will then be putting the human-centric at the center by inviting the readership visibility, the collaboration, the recognition, and the continuous training that should happen as long as the organization exists.
Okay, ma'am,
Now,
thank you so much and congratulations.
Thank you, Doctor.
Thank you, ma'am. Thank you, Chair.
Thank you.
We'll be moving towards our next presentation, and the next presentation by Abhijit S. For the paper title, Optimized Model Protect Prediction using SMT, Switch and Mini Batch Gradient Descent Optimizer.
Good evening, everyone. Is my screen visible? One minute. Is it visible now? Is it visible now?
Yes, please.
Yes.
Go ahead. Yes, Abhijit, you can start now.
Yeah. So basically, my topic is an optimized model for heart attack prediction using SMART, Swish, and mini batch gradient descent optimizer. And so coming to the introduction, why we actually want to do this project. So recently, the healthcare community, especially in the heart-related disease, it was increasing due to the lifestyles and our food habits. So due to these reasons, the health style, diabetes, heart attack prediction, cardio-related diseases started increasing. Especially in India, it has emerged as bird region, like 1/4 of the global community cardiovascular deaths are happening. And the reports are saying like that in next 5 years, the projections of this will be increasing. So there is a huge scope for our project. And coming to the gaps we found out from the literature reviews, basically, as you can see, the project was existing already, but still, when we check the other research papers, we identified that the most of the papers were using the traditional model for making the machine learning model. But in 2018, actually, they have released one paper related to a model called Swish. So instead of using that ReLU, which was the traditional activation function, we were trying to implement that activation function inside our model. That was one of the gaps we found out when we were doing the literature survey. Another one was called this mini batch gradient descent. When we are training the model, we applied this particular method. We splitted the epochs into batches so that it was giving more accuracy for the model. So coming to the problem statement, there was actually a lack of predictive models that simultaneously incorporate advanced activation functions, address class imbalance effectively, and ensure efficient convergence through the optimized training strategies limits the development of accurate and deployable systems for heart attack risk detection in real-world clinical settings. So based upon this problem statement, we came up across a proposed methodology. So the data set, we actually take it from Kaggle, and then we applied pre-processing techniques on top of that. Like one of the technique was finding out the correlation between that. Another one was trying to normalize the data set. And then actually this oversampling method which we have implemented, that is for the purpose of class imbalance. So the method we were used was a synthetic minority oversampling technique. So that was actually one of the research gap also we have found during the literature review part, because in the other papers they were not discussing that much about the class imbalance happened before the training. And after that, we have trained the model in a ratio of 80 to 20 ratio. That is a common ratio they were using for training and testing. And then we created one 6-layer feed forward neural network actually for this. And the first input was ReLU, followed by, instead of ReLU, we started using a swish activation function inside that. So swish is actually chosen for its smooth and non-monotonic behavior, which supports better gradient flow and model convergence. So that was actually one of the novelty we found out during the project when we were doing. And this is actually our workflow, if you can say. Like, first we took the data set, it was a CSV data set, and then we found out the correlation analysis. Then we applied a SMART, as I discussed, to remove the class imbalance. Then we sent it for the training and testing purpose. Then we created one 6-layered neural network based upon the tuning. We have used other layer network also, but this was the best fit output we got after the tuning purposes and all. And then inside that, as I told, we were using a swish along with that one dropout layer also we were using for that. And then for optimization purposes, I have used Adam optimizer. And then in the end, when we are training the model, we used mini batch gradient descent. And finally, we were trying to predict the output and get the evaluation from that. So yeah, as I told, this mod is actually used to remove the class imbalance inside the data set. And then dropout layer have applied with the dropout rate of 0.2. And then the final output, we were actually applying a sigmoid as an activation function, because it will give in the range of probability, so that we will get the output whether it is having any heart attack or cardiovascular disease or not. So for binary classification, we implemented a sigmoid in the output layer. That is one single neuron will be having in the final output layer. So as we discussed, as some of the other presenters discussing in the earlier presentations, we were having three layers, like input layer, then hidden layers and output layers. So that layers I'm talking about in detail. And in the optimizer, we have used Adam with a learning rate of 0.001. That also we tried to use after the fine tuning method. We were checked with other learning rate also. Then we got to know that, and we understand that this learning rate was giving more accuracy. And binary cross entropy we have used as loss function, because we need binary classification in the end. So the next was the data set. As I told, it was a data set from Kaggle, which is having the physical attributes like glucose level and BMI, age, pressure, insulin level and all. The data set was having around 768 data with 8 input features and one binary target variable for it is representing the medical condition, whether the patient is having the cardiovascular risk or not. And then these were the data set we are having, and the description and the range of that. So almost 8 we were used, and one output label data set was there. And then coming to the pre-processing methods, the main thing was finding out correlation analysis. Earlier also during the presentation, sir was asking like why we have to how we are finding out which are the best features suiting for the outcome. So for that purpose, we have actually implemented here the correlation analysis. As you can see here in the table, this was the data frame I created while doing that. And we were trying to check how much the other features are related with the outcome. As you can see here, if you are checking the outcome with outcome, you can see one, that means it is highly correlated. And then other features also you can see around 0.2, 0.4, 0.06, 0.07, 0.13. So whichever is giving the high rate towards the outcome, that only we were mapping after that. So as you can see, this is the Pearson correlation method we have applied. The equation will be like R equal to sigma xi minus x bar into yi minus y bar divided by root of sigma x of xi minus x bar the whole square into yi minus y bar the whole square. So that R value actually relates between -1 and +1. R equal to 1 indicates the perfect positive relationship. R equal to minus means a negative relationship, and R equal to 0 means no linear correlation. So as you can see here, the range also it will be varying from -1 to 1 in the outcome. So we have choose the best fit features for the proceeding of the project, and then we applied this mode. So this was the actually one of the major thing we implemented from our part rather than the other papers we have checked. So as I told, the when we took this data set, we found out that there is a class imbalance in the data set. That means 50 cases were there in the negative class, that is no elevated risk, and 268 cases was there in the positive class, that is elevated risk. So we actually want to make this both the amount of the data in the both classes should be same. So for this purpose, we should implement one oversampling technique. And by the research, we understood that this synthetic minority oversampling technique is one of the best method we can implement, so that we can increase this positive class also into around that 500 level. So basically, we are trying to implement the class which is having less numbers. So after applying this mode, the dataset will get an equal representation of both classes. That's what we first tried to implement. So this is actually one diagram of that class distribution before SMOT and after SMOT. Sir?
Just wanted to let you know the time limit.
Sir?
I just wanted to let you know of the time limit here.
Yeah. I will go ahead first. Sure. So then we have done the testing and training part, 80:20 range. And then this was the model we have applied. 3 dense layer, 1 dropout layer, then again 2 dense layer, in which last one is the output layer, which we are having activation function as sigmoid. Other activation functions we have used as swish instead of ReLU, so that we got a better output. And then this is the same related to the layers we have used. And then this was the difference between ReLU and swish. So in swish, we were not concerned about the negative values. So even if the equation, if you check here, ReLU of x equal to max of 0 of x, so that negative values, whatever is there, they are considering it as max of 0x. But in swish, we are considering that weights also for the model training, so that that bias won't be happening that much. So swish is actually x into 1 by 1 plus e raised to minus x. So that is more smooth, non-monotonic, and it also allows small negative values to pass through, which helps to perceive the information during the training. So next one was about the optimization strategies. As I told, I have implemented ADAM for the optimizer than the SGD ADAGRAD RMS probe, because this combines the benefit of ADAGRAD and RMS probe. So this is the equation for that. So, during to the time regulations, I'm not going to that much. Then coming to the results that we got, first thing we were checking was whether the model got overfitted or not. So by checking the training loss and testing loss, we found out that there is no gap is there in between. So we came to the conclusion that the data set actually trained properly, so that there is no overfitting or underfitting happen. And it was not having that much loss also, the loss also going almost correct only. And then this was the confusion metrics we got from the experiment. So our accuracy was almost 96.75. This based upon true positive, true negative values, we have got that. And then similarly, what was the true positive value, true negative value, false positive and false negative we got. From that, we came to the accuracy that 96.7 was the accuracy of the model. That means the model is predicting good. And then coming to precision, recall, and F1 score also, it was giving a good amount. And these were the reference papers we referred, almost 17 papers we referred. And in that, the first paper, which is Swish as self-gated activation function, was the key paper that we referred for that, implementing that new activation rather than the traditional one, and then training the model. So that was about the project in brief.
Okay, Abhijit.
Yes, sir.
It's a good research.
Thank you, sir.
But I want to just share a few things with you, right?
Yes, sir.
First thing is, when you choose a medical domain or a healthcare domain, right?
Yes, sir.
Publishing a result, it's a very dangerous, right? Until and unless you are more than 100% sure, right?
Yes.
Second thing is you are working with some synthetic data or a data
Yes,
set which is available on Kaggle also, right?
yes, sir. Yes, sir.
Yeah, it's not a real data, what I'm referring to, right? So, yes, research point of view, from a technical point of view, it's really a good work, right?
Thank you, sir.
The only concern is related to the application, right? I
Yes, sir.
mean,
That's what actually I was also
the
trying. Like,
question,
yes, sir.
yeah, the question is how much to rely on this result and to take a decision real time in some, healthcare or a medical domain, right?
That's what I told, sir.
Uh,
Actually, we were getting a good accuracy, and I think even if we are getting the real-time data for this, it will give a good accuracy because we have checked
so
about the.
matter, yeah, yeah, you should have to try for a real time data,
That's what, sir.
and
Actually, in the future
it
scope
should,
also, we are planning for that. The problem is, it's a medical data, right? So when we are approaching hospitals or something, that issues
yeah,
come a
but
little bit, but still, it is there in the future scope, sir.
okay, fine. And the second thing is related to the overfitting and underfitting, right?
Yes, yes, sir.
It's not about to take care of the size of a data for that. What matters for overfitting and underfitting is how much variance is available in the deleted data,
Mm-hmm.
right?
Yes, sir.
And that you only get when you have a real-time data. Uh,
Okay, sir.
because the variance defines whether the data is, I mean, the model is overfit or underfit with
Yes,
relevance to your data. It's not a size, right? Okay.
yes.
Yeah, thank you.
I was not only talking about the size, sir. Actually, the uh, gap between the training loss and the testing loss, that also we checked the validation loss. So that was also actually giving less gap in between. So that we felt like the underfitting or offitting didn't happen. Not only
Okay.
the size of the data.
Okay, sure.
Yes, sir.
Yeah.
Thank you, sir.
Instead of having questions, I'll be having suggestions instead.
Yes, sir.
Maybe you could consider validators or the professional validate or expert validators of this research. But I do agree with Dr. Bat that data set from Kaggle is not that really a real data. So maybe
Okay.
you could consider real data later on and consider
Yes,
also
yes.
your validators. But
Okay.
Yeah.
anyway, thank you for the presentation and congratulations.
Thank you, ma'am. Thank you, sir, so much for giving this opportunity. Can I stop screen sharing, sir?
So yes,
Thank you.
good clear. The last paper to be presented, secure e-voting which fully homomorphic and present the Smoky Wiki. You have the author or you have the author's statement? Name is not. Moving ahead, I sincerely thank the excellent presentation to contribution in this session. Being part of this international movement. I hope this session was informative enough. We will be up. Thank you for the support during this version of the conference. We will be happy to have you in the next version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Publication will be live within 7 to 8 months. Kindly cooperate with the team of MCT4SD 2025. Our session chair, Dr. Janelle M. Mendez, for chairing the session. Ma'am, here is the token of appreciation on behalf of Team MCT4SD 2025 and Global Knowledge Research Foundation and partners. Ma'am, I request you to please share your closing remarks with us.
Okay. Again, thank you so much. I thank everyone for contributing to a productive and intellectually simulation session. And we hope that this insight share or inspire the further collaboration, the refinement of these studies, and future research that continues to address now pressing societal and technological challenges. Again, thank you so much for everybody.
We also thank our session chair, Dr. Nirav Bhatt, for chairing the session. So, here's a token of appreciation on behalf of Team MCT4SD 2025 and Global Knowledge Research Foundation and partners. So, I request you to please share your closing remarks with our author.
Sure. Yeah, first of all, thank you very much, MST4SD, for providing this opportunity to chair the session. All the research paper presented were good. Some of them were very good. A few things where I think if researchers are present in this meeting, need to know about like how to present the research work. You have probably done a lot of work, but the way you have presented can further be improved. And considering the time limit, how to bind your presentations within the time limit and still effective and impactful. That is something where you guys have to work on. And second thing is whatever suggestions are given by the chairs, session chairs, here you can work on it and you can expand your work. Don't stop it here. Thank you very much.
Sir, I thank you all for your valuable presence. At last, I kindly request you all to switch the camera for a quick snapshot of the virtual conference. Requesting all first turn on the camera for a quick snapshot of the virtual conference. Thank you all. Stay safe and take care.
Yeah, bye. Take care. Yeah, thank you, Janelia, ma'am.
Thank you so much, Dr. Bat. Nice meeting you virtually. Thank you, everybody.
Yeah, thank you. Thank you very much. We'll keep in touch with you.
Thank you, ma'am.
Thank you, sir. Thank you, ma'am.